Hi guys, welcome. Today we are looking at Math 6, Day 21. We are going to be looking at lessons 64 and 65. So classifying quadrilaterals is our first lesson. So remember, quad means four. Quadrilateral is just a type of polygon that has four sides. So we have different types. We have a trapezium where no sides are parallel, a trapezoid where we have pair of parallel sides and then the other sides are not, parallelogram where both sides are parallel, a rhombus parallelogram with equal sides, and then a rectangle parallelogram with right angles, and then a square, a rectangle with equal sides. So it can kind of get grouped and categorized down as we go. So a square is also a rectangle, is also a parallelogram, is also a quadrilateral. So it could refer to a few different shapes. Okay, so if we look at example 1, is the following statement true or false? All parallelograms are rectangles. Well, let's look back up here. A rectangle is a parallelogram, but we were asked if all parallelograms are rectangles. And we see right there, that's an example of a parallelogram, and it's not a rectangle because we have two obtuse and two acute angles. So right there, we know that it is false. Okay. Example 2, draw a pair of parallel lines and draw another pair of parallel lines. If you have your ruler, you can use the ruler to keep them separated. Again, parallel means they're never going to cross. We draw our two sets of lines. These lines should intersect the first pair, but not be perpendicular to the first pair. What is the name of the quadrilateral that is formed by the intersecting lines? If we were to look at it right here, parallel lines, and then two more parallel lines. Again, they're not perpendicular, meaning they're not making right angles. The shape that is formed is a parallelogram. So again, we've worked with a lot of different polygons and shapes. Today's lesson, when we go over the practice set in class, we'll focus in on just quadrilaterals, which means four sides. It's not always a square, rectangle, a few different types of quadrilaterals as we just mentioned. Okay, then we have lesson 65, prime factorization, division by primes, and factor trees. So a few different ways that we can look at this. Again, a prime number means that only one in itself goes into it. So we can keep breaking down even the biggest of numbers until it's prime factorization and it's a multiples of all prime numbers. So 4 we could write as 2 times 2, 6, 2 times 3, 8, 2 times 2 times 2, and 9 we can do 3 times 3. So that's called prime factorization. We're breaking it down until obviously we're left with only prime numbers, and it would still be equal. 3 times 3 is still equal to 9. 2 times 2 times 2 is equal to 8. So we're not changing the value, we're just writing it in a new form. So we can do division by primes. Again, like when we're factoring out of a fraction, we know a number that goes into it. 60 divided by 2 is 30. 30 divided by 2 is 15. And then 15 divided by 3 is 5. 5 divided by 5 is 1. Okay, so we got to where we have all prime numbers. So 2 times 2 times 3 times 5 would be our prime factorization. I want to show you factor trees just because I think this is easier, because no matter where you start, you're going to end up with the same answer. And I think it visually makes a little bit more sense, at least to me. If you like division by primes, you can do that. But if we had 60, and again, I'll show you can start with any number you want. 6 and 10, that's an easy one. Both of those are composites, so we got to keep going. 3 times 2, and those are both prime numbers. For 10, we get 5 times 2. Both of those are prime numbers. So we have 3 times 2 times 5 times 2, and we can multiply in any order, so we can move those around. let's say we started with 30 times 2. Well, we should end up with the same thing. 5 times 6 or 15 times 2, doesn't matter. 5 is prime, and then we have 3 times 2. 5, 3, 2, and 2. 5, 3, 2, and 2. Same thing. A little different order. We started with different numbers. But this one, to me, just visually makes more sense. We can see no matter where we start, as long as we're doing the factoring correctly, we're going to work out to be the same prime numbers. So that's the method I prefer. If you like the division by primes, you can use that as well. And so if we look at example 2, they use 4 and 15, the same number we started with. Okay, 4 and 15. From 4, we get 2 times 2. From 15, we get 3 and 5. 2, 2, 3, and 5. Exact same thing we got doing it 2 other ways. So that's why I like that one, just because it's it doesn't matter where you start, you're going to end up with the same answer. You'll still get the same answers if you do it division by primes. It's just, I think that one you're going to take a little bit more time, but if you like it, then by all means use that method. So we'll work with both when we get to class. Again, remembering what a prime number is and what a composite number is important. So we can't do division by, or we can't do prime factorization if we're starting with a prime number, because we can only factor 1 in itself out of it. All right, we'll go over these practice set problems in class together. That will be it for this video. Thank you, and we'll see you soon.